Hello friends, welcome back, and in this lesson we are going to talk about learning objectives of our fourth module, that is natural language processing, NLP. And similar like last module, we are going to have two sub-module here. And in the first sub-module, we are going to discuss about the features, the capabilities of NLP, like what NLP is all about, what are different types of features, different types of applications we can have of NLP. And we'll discuss about key phrase extraction, entity recognition, sentiment analysis, language modeling, speech recognition and synthesis, translation. And then in the second module, very much like previous module, we'll discuss about Azure tools and services to implement all these features. Like what are different services we have. We have text analytics service, which cover first three features of NLP. Similarly, we have LUIS or language understanding and service, which cover the language modeling. We have speech service here, which cover the speech recognition and synthesis. And we have translator text service, which cover the translation feature of NLP. And once again, we are going to see a lot of examples and applications and demo in this module. And this is going to be interesting. And before I finish, I forgot to mention that this module is also going to cover 15 to 20% of the syllabus, like most of other modules. So once again, without getting delay, let's get into it. Thank you. Hello friends, welcome back, and the goal of this lesson is to understand natural language processing, NLP. So what is NLP? NLP means when we trained our computer in such a way that computer can understand and interpret human-like language. So understand. What after understand? Once computer understand, then try to find out the intent behind that text, that language, that instruction. And once computer understand the intent, computer take action based on the intent. So let me show an example here. So this is the example from Microsoft website. And here you can see that we have a table lamp, and we have a floor lamp. And then you can give some kind of instruction here. So for example, I can say, can you please turn on all the lights? And you can see that table lamp and floor lamp both were off before, but after taking this instruction, our computer turned on them. Now this is very human-like language. This is not some kind of XML or some kind of syntax-based language, but still computer understand, computer find the intent behind that and take action on that. So for example, let's take another example. I can say, can you please turn on or off table lamp? And you can see that table lamp went off this time. So this is just one type of example of NLP. And if you have been following this course, in the very first module, there was a lesson on identifying natural processing language, where I discussed so many different examples and I showed so many different applications based on NLP. And I highly encourage you to please look at that lesson one more time if you have not already. So the goal of this lesson will be to understand what are different features we have for NLP. So for example, we have key phrase extraction, entity recognition, sentiment analysis, and the application we just looked at, like table lamp and floor lamp, that was example of language modeling. And then we also have speech recognition, synthesis, and translation. So in the upcoming lessons, we will look at all these different features in a little bit more detail. Thank you. Hello friends, welcome back, and the goal of this lesson is to understand first three features of NLP, that is key phrase extraction, entity recognition, and sentiment analysis. So let's look at first the key phrase extraction. So key phrase extraction, as the name suggests, it is basically to extract the key phrases from the sentence. So basically it's just figuring out the key points, main talking points out of the document, so that we have some idea that what document is talking about, what is the key points we can take away from that document. So for example, let's take this example here. We had dinner here for birthday celebration and had a fantastic experience. So this is a phrase here. We were greeted by friendly hostess. This is another. Taken to our table right away. The ambience was relaxed. Food was amazing. Service was terrific. If you like great food and attentive service, great food, you should try this place. So if our service can extract these phrases, we have an overall idea about the sentence. That is key phrase extraction. And you can look at this here. This may be important from certification point of view. You may get question here that key phrase extraction works better when you provide it with a bigger amount of text. So the more text you have, the better you will have understanding of that sentence or that document in general. All right, so the next one we have is entity recognition. So this is basically is to figure out what are different entities we have in our sentence or document. Entities like maybe name of person or location or organization, some kind of quantity, some kind of date or time, or maybe some kind of URL, email, phone number, maybe IP address. So what are different entities we can find out in our document? So for example, if you look at this sentence here, I ate at the restaurant in Seattle. Seattle is entity. Last week, this is another entity we have here. All right, so let's move forward here. And the third one we have sentiment analysis, and this is so very useful in social medias or in customer reviews and the discussion forum when we want to know the sentiment of our customers, of our visitors, and we have hundreds and thousands of reviews and then comments and all, and we want to know that how many of them are positive or negative. So this is so very helpful in that. So for example, this is the first example of positive sentiment. And if you look at here, we had a dinner at the restaurant last night, and the first thing I noticed was how courteous the staff was. So this is courteous the staff. This is positive sentiment. We were greeted in a friendly manner. Taken to our table right away. The table was clean, chair was comfortable, and the food was amazing. So look at these keywords. Our service can identify that this is about the positive sentiment. So, and this is another example of negative sentiment. Our dining experience at this restaurant was one of the worst I have ever had. The service was slow and the food was awful. I never eat at this establishment again. So once again, this is an example of negative sentiments. And when we have, for example, hundreds and thousands of such comments or reviews, we can use NLP service to analyze those comments and reviews and basically have a compile information about the sentiment of the people, of the customer or the visitors we have on our website or social media or into different application, discussion forum, or so on. Another thing you want to notice here is that sentiment analysis perform better on smaller amount of text. So the smaller amount of text we have, the better NLP model will be able to analyze this sentiment, and it produces the high quality result with the smaller amount of text. And we will look at this once again, but the service we have in the Azure, it provides a sentiment score in the range of 0 and 1. So the more it is closer to 1, the more positive sentiment our model think we have. We will look at this once again, but here I just wanted to make sure that you understand what sentiment analysis is. Now let's look at some of the questions based on these features. So for example, the first question is, now we have to look at these statement and figure out if they are true or not. So the first one is sentiment analysis return sentiment labels and scores for the entire document. So I request you to maybe you can stop this video here, take few minutes and make sure you have your answers, and then continue this video and just match and to make sure you have the right answers. All right, so the first statement we have is sentiment analysis returns sentiment labels and scores for the entire document. Is this right or wrong? This is right. So as we just discussed that sentiment analysis evaluate our text and then return sentiment label like it is positive or negative or neutral. And it can work on both. It can work on the entire document, or it can also work on just maybe single sentence. Now, the next statement is sentiment analysis return sentiment labels and scores for the each sentence within a document. Is it true or false? So the answer of this is once again true. So basically, as part of sentiment analysis, sentiment labels are applied to text and at a sentence or at the document level, as we just discussed above. We can have at the sentence level or the full document level, and it gives a confidence score for each label, for each sentence. It may be positive, it may be negative, it may be neutral. So it does with the it does work with the each sentence in the document. Confidence scores range from -1 to 1. Is it true or false? This is false, as we discussed that it's range from 0 to 1. When the score get closer to 0, it indicates the lower confidence, while score closer to 1 indicate higher confidence in the relevant label classification. So confidence score for the entire document and each sentence within it adds up to 1. All right, so let's move to the next question here. Another question is, which two of the following can be found in a text document by using entity recognition? Each correct answer presents a complete solution. So entity recognition, this is what we need to find here. So once again, you can stop this video here if you like, and you can come back. So answer of this is dates and times of the day and the passport number. So entity recognition can also find, the date, time, date range in the text. And entity recognition can detect personal information like social security number, maybe driving license number, passport number, and so on. So these two are the right answer. Now, it is not emotional expressed, because this is an example, if you remember, of sentiment analysis. Sentiment analysis. And if you look at intent and action, again, this is not entity recognition. This is an example of language understanding. And main taking points, as we discussed, this is an example of key phrase extraction. All right, so let's move to the next question. Which requirement would require you to use sentiment analysis? So if you look at this carefully, analyze social media for a brand. This is an example of sentiment analysis, where we analyze maybe the reviews, the comments of our customer, of our visitors through sentiment analysis, if they are positive, negative, or neutral. And if you look at other examples, for example, extract brand information from the document. Now, this is not sentiment analysis. This is an example of entity recognition. Transcribing the recording of a marketing presentation into text. This is example of speech. We will, look at this in the next lesson. Find the use of brand names in the document. This is the content moderation. But sentiment analysis, where we analyze the reviews and the comments of a customer. Okay, let's move to the next question here. And once again, you can stop this video here and come back as soon as you have the right answer. All right, so let's look at these statements one by one. Understand how upset a customer is based on the text contained in the support ticket. Is it sentiment analysis? So we are talking about how upset our customer is. So basically, we are looking at the sentiment of the customer, whether he is positive, is negative, or neutral. So this particular statement is right. Now the next one is summarize important information from the support ticket. Now summarize important information. It is like taking away the key points, key talking points of the document. Is it key phrase extraction? Yes, it is. This is what is the definition of key phrase extraction. So this second point is also correct. Third one, extract key dates from the support ticket. Extract key dates. So name of the person, phone number, IDs, dates, time, all these are entities, and extracting these entities is part of entity recognition. That's what we discussed in this lesson. So once again, this is right. So very first statement is the right answer. All right, so I hope now you have a better understanding and you understand the difference between sentiment analysis, key phrase extraction, and entity. Hello friends, welcome back, and in this lesson we are going to talk about language modeling. So once again, what is language modeling? When computer understand human-like language and can extract the intent behind it and also can take action based on that, that is called language understanding. So basically our model should be able to understand the intent, and based on this intent it should be able to take the action. So if you remember a few lessons back, we discussed about this example where we have table lamp and the floor lamp, and we give some kind of command here. For example, can you please turn on all the lights? And you can see that our system understands this human-like language and the intention behind this language, and also take action by turning on all these lights. This is called language modeling. And there can be many applications we can have based on this concept. For example, we can have a customer support application. We can have reservation systems. We can have home automation. We have, Google Assistant, Siri, all of these different applications we have behind the scene. They are using the language modeling. Now, the three main concepts in the language modeling, which is utterance, entities, and intent. So if you look at this sentence here, for example, turn on the light, this whole thing is called utterance. And what is the entity in this sentence? If you look at this, light is actually an entity here. And what is the intent? Turn on, this is the action, this is the intention of this sentence. So the whole thing, this is utterance, this is entity, and switch on, this is the intent of the sentence. Now let's look at one question based on this concept. So we have few statements here, and you need to figure out if these statements are right or wrong, true or false. So you may stop this video here and come back as soon as you figure out the answer. All right, so the first statement is language modeling can determine the emotion in a text statement. So can language modeling determine the emotion? No, language modeling cannot determine the emotion. Language modeling can determine the intent, can take action, but emotion is not something which language modeling figure out. This is something which can be figured out through sentiment analysis. If you remember, we discussed this earlier. Now the next one is language modeling. So basically this is false, this is wrong. Language modeling can discover the meaning in the text sentence. Yes, meaning is something which language modeling can figure out. Once again, the intention behind the sentence, the information, and can take further action based on that. So this is true. The third one, language modeling can detect the language the text is written in. Can language modeling determine the language? Once again, no. This is the job of language detection, not language modeling. Language can be determined by language detection service, not language modeling. So once again, this is false. All right, so I hope now you have better understanding about language modeling. Thank you. Hello friends, welcome back, and in this lesson we are going to talk about speech recognition and synthesis. So what is speech recognition? So in very simple terms, you can understand that when you want to convert the speech, the audio, into a text, this is called speech recognition. Now this can be a live audio, this can be an audio file, And when you convert it into a text format, that is called speech recognition. And on the opposite of this, if you have a text data and you convert into an audio file, that is called speech synthesis. And Microsoft has application which I can give you a quick demo here. So for example, if you look at these cognitive services, inside speech you have speech to text and you have text to speech. So if I look at this speech to text here, if I speak something here, our system will be able to understand my voice and will be able to convert it into a text. So for example, let's take a demo here. So my name is Ishant Garg, and right now I am recording a course for artificial intelligence certification. My goal is to make sure that all students who will take this course should be able to clear certification with the ease. Thank you. So I'm just waiting for this to finish here. Now you can look at this here. So I can stop it here and you can see here that whatever I was speaking, my name is Ishan, this and that, and this model was able to recognize my speech, my audio, and on the live at the real time able to convert it into a text. And on the opposite of this, we have text to speech. So if I type something here and if I click on this play button, our system is able to read this text and convert it into an audio file. And we have different options here. We can choose different characters here, maybe a male or female, and they have different kind of voice here. You can choose the voice style here. You can change the speed of the speaking and the pitch of the audio file. So you have quite different options here to change the audio file according to your need. So let me go back to my slides here. So this speech recognition can be used in different applications, like you can use it to transcribe the phone call here, or you can automate your note dictation, or maybe you may be determining intended user input for further processing. Similarly, speech synthesis can be used, for example, in voice menus for telephonic systems, or maybe generating spoken responses for an user input, or maybe reading an email or the text aloud for hands-free scenarios. And this is also very helpful in people with disabilities like vision impairment. For them, this email and text messages, this can be read by this service since they cannot see this. So all right, so let's look at a few questions based on this concept, and you can expect very simple questions in exam. So for example, this is you need to build an app that will read recipe instruction aloud to support a user. Recipe instruction aloud to support a user who have reduced vision, physical disability. So which service, which API can do that? So the correct answer is obviously speech. Speech is something which can read our recipe instruction aloud, or I should say speech synthesis is the correct answer. Now the next one is in which scenarios can you use speech recognition? So once again, speech recognition means converting your audio, your voice, your speech into a text. So if you look at the first one, providing closed caption for recorded or live videos. Yes, this would be a right answer. We can convert these audios into a text file. In car system that reads text message aloud. Now this is not an example of recognition. This is an example of speech synthesis. So this is wrong answer. Creating an automated public address system for a train station. Of course, this is wrong answer. Creating a transcript of a telephone call or meeting. Yes, this is a right answer. We are creating a transcript. We are creating a text from a video or the audio file here, telephonic call. So this is the audio file here. So I hope now you have a better understanding about speech recognition and synthesis. Thank you. Hello friends, welcome back, and in this lesson we are going to talk about translation API, which is another very interesting cognitive service API. So what is translation? So basically ability to translate either the text or the speech from one language into another language. So when we try to convert text from one language into another language, or if you're speaking in some language and you want to convert that into another language, that is something we can do through Translation API. Now, why this is important and how this is very special through native literal translation. Now, there are few issues with the literal translation. Sometimes we were not able to find the equivalent word in the targeted language. In every language, there are few words, and it is often difficult to find equivalent word into another language. So in those cases, it was not working. And sometimes even the context or the meaning of the sentence also change if we just use the exact word, exact translation into another language. So for example, in the French phrase, this is a French phrase, and if we convert into an English, this is turn off the light, which is fine. In the French also, it means turn off the light. But if we change this word with another word here, in the French, this still means turn off the light. But if we change this word into an English, it says close the light. Now, if someone who is, general, normal, English speaking person, close the light does not make a lot of sense here, right? So that's why this is the kind of issues we used to face when we used to do the literal translation. And this is how this artificial intelligence based translation API is so very special. Now, as I said, there are two things here. One is to translate document or the text from one language into another language. And there can be many applications based on this. For example, you can have the ability now to translate your web page, and you might have seen that sometimes you open the web page, and on the side of this, on the top right corner of that page, you see the option to convert the whole page into some other language. Or you can do the email communication, and that basically translate that email communication into some other language. And the second one is, as we just discussed about the speech translation. So basically you convert your speech to speech translation, one speech into another speech, or maybe you can have speech to text in this. So let me show you an example here which Microsoft has given us. So this is the cognitive services page here, and within speech, if I go to speech translation here, this is the page we have. And you can see that I can speak something here, and on the real time, it is supposed to translate into some other language. So for example, let me choose, for example, my native language here, which is Hindi, so that I can verify the translated text, the final translated text we have is accurate according to what I speak here. So let me try this here. My name is Ishant Garg, and I'm recording this course for artificial intelligence certification. And I hope that this is going to be very interesting course, and all the students who are going to take this course should be able to clear the certification with very good marks. Now let me stop this here. And now those who understand Hindi, in Hindi it read like, मेरा नाम ईशांत गर्ग है, मैं आर्टिफिशियल इंटेलिजेंस सर्टिफिकेशन के लिए इस कोर्स को रिकॉर्ड कर रहा हूँ, और मुझे उम्मीद है ये बहुत दिलचस्प कोर्स होने जा रहा है, और सभी स्टूडेंट्स इस कोर्स को लेने जा रहे हैं बहुत अच्छे अंकों के साथ, प्रामाणिक क्लियर करने में सक्षम होने चाहिए. So this is very accurate. This is, I would say, 99% accurate in Hindi language according to what I speak in English language. So this is the application where we can at the real time convert our speech, our audio file into another language, into a text. And this is another very common example. I'm pretty 100% sure that you might have used this many times. If I write something here, it is able to translate into some other language here. So for example, once again, my name is Ishant. I am recording course here. मेरा नाम ईशांत है, मैं यहाँ course record कर रहा हूँ, which is pretty good. So I hope you have used this application many times. Now you know that behind the scene, we are using this translation API to convert text or the speech from one language into another language. I hope now you have a better understanding about translation API. Thank you. Hello friends, welcome back, and in this lesson we will see that how in the next few lessons we are going to look at Azure tools and services we can use to implement NLP. So in last few lessons we discussed about different features we can have for NLP. So for example, we discussed about key phrase extraction, entity recognition, sentiment analysis, language modeling, speech recognition and synthesis, and translation. Now the question comes, how to implement these in Azure? What are different tools? What are different services in Azure? Using those services or tools, we can implement these features. That's what we are going to look at in the next few lessons. So for example, first three features: key phrase extraction, entity recognition, and sentiment analysis. These three features can be implemented using service called Text Analytics Service. We can use the LUIS or Language Understanding Service to implement language modeling. Similarly, we can use Speech Service to implement speech recognition and synthesis. Or we can use Translator Text Service to implement translation. Now, we have option either to create all of these services separately. All these are separate services. We can create them individually, or we can create a cognitive service. As we know, as we have been doing in previous demos, using these services, we can actually implement all of these different features. So if we just create cognitive service, we don't have to create all of these services individually. However, there's a very small exception in case of a language understanding service. We still need to create this service to train. But if we publish them and when we want to use them, we can just use cognitive service. And I will explain this in that lesson individually in detail, that how and when we need to create this service separately. But the point is, but in general, if we create a cognitive service, we don't have to create all these services separately. Now, if you have been following this course, we are actually using these Python scripts, these notebooks, to show you the demo. And this is these are the demos created by Microsoft. And in the previous lessons, I showed you how to copy these from GitHub. And I hope you have been following this course and you know this by now. If not, for whatever reason, you can look back and copy these files from GitHub. Now, in the next few lessons, we will look at all these different notebooks for text analytics, speech, translator, and language understanding. And we will see that demo for all these different services. But the point here is for this certification, you don't need to know actually how to use this service. You need to know what these services can do. So you will see questions like, for example, you have a chat application and you want to implement functionality to enable English to Korean translation. Now, which service will you use? So if you know the purpose and the functionality of this service, you know that for this feature we will use translator text service. Similarly, you need to know for what purpose we use this service. What is the use of these services? You don't need to know how to use this service. You don't need to know the code. You don't need to know the implementation of these services. So, but still, we will go through the demo for these services so that you have a better understanding, you feel more familiar with these services. So without taking a lot of your time, let's start with the text analytics service in the next lesson. Thank you. Hello friends, welcome back. And the goal of this lesson is to understand text analytics service. So as we discussed earlier, that this service support NLP, natural language processing features related to text mining and text analysis. And this service we can also use with Power App, and there's also a connector, and using that connector we can use this service from Canvas app, and this can be important from certification point of view. Now, as we discussed, this service support 4 features: language detection, key phrase extraction, named entity recognition, and sentiment analysis. We have already discussed these three in the previous lessons when we were discussing features of NLP, and language detection is another feature which is supported by this service. And this is very simple, that if you provide a text to this service can identify the language in which that particular text was written. So for example, if you provide this text 1, review 1, the fantastic place for lunch, the soup was delicious. Now service can identify the language of this text, which is English. Also service return ISO 6391 code, which is EN for this language, and also return the score, which vary from 0 to 1. The more closer it is to 1, the more confident the service is about the identified language. Now, the second one is comida, maravilla. I cannot read Spanish, but this is a Spanish text, and the service identified that this is the Spanish text, this is the code, and this is the score. So service is pretty confident about this. Now, in this third review, this is interesting here. This is a mix of English and another French language. But if you look at here, service still identified this as English. Why? Because English is the predominant language in this text. So text may be written in more than one language, but if one particular language having a more percentage in the text, service return that particular language. And once again, the code and the score, that 0.9% confident that English is predominant language in this text. So language detection is one of the feature of text analytics service, and we have already discussed earlier about the key phrase extraction, named entity recognition, and sentiment analysis. I will quickly go ahead and give you a very quick review about these features just to make sure that you are comfortable and aware about this. So key phrase extraction means when we extract the key phrase, the main talking point about the sentence. For example, in this sentence, the fantastic experience is the phrase, great food, friendly hostess. So all these are expression, the phrase we can fetch from the sentence, and that gives us the idea about the line or the document. And the next we have entity recognition, in which we find out the entities within the sentence. So it can be location, it can be a time, for example, the last week, it can be a phone number, it can be a passport number, it can be a email, or maybe some kind of quantity or something. And not just it returns the entity, it also returns the type of entity. As I said, for example, the location, date, time, phone number, passport. So this is the type of entity, and this is a subtype of entity. And not just that, for some of the entities, it also returned the Wikipedia link so that we can figure out the more information about that particular entity. And then we have sentiment analysis, in which this service identified the sentiments in the customer reviews or the discussion forums and so on. And with the sentiment, it also returned the value from 0 to 1. More it is closer to 1, that means the more positive sentiment it is. If it is closer to 0, that means it is negative. And of course, around 0.5, it will be neutral. All right, so let me take you to the portal and show you that how we can use this service here. So right now, I'm using these notebooks. And once again, I hope that you have been following this course, and we are using all these notebooks created by Microsoft with a detailed document, and these are very good demos. So we will look at this text analytics demo. So this first cell will let us know that what is the text we are trying to analyze here. So you can see that we have 4 reviews here, review 1, review 2, 3, and 4, and this is submitted here. I mean, if you look at this location, data, text, and reviews. So if I scroll up here and go to data and then text and then reviews, you can see that we have these as an input text here. So this is review 1. Similarly, we have review 2, 3, and 4. This is basically the input we are trying to provide to our service. Now, the next thing is very obvious. We want to authenticate to our service, and we have cognitive service. And once again, if you want, you can create a separate text analytics service here. Text analytics playground, discover insight. Or if you have a cognitive service which we created in our previous lessons, you can just directly use that service. So we can take a key and endpoint from here, from our cognitive service, and we provide here, and we can authenticate ourselves to this cognitive service. And the next thing is once again, we want to install the package for text analytics. So once the package installed, we are ready to use this service. So the first thing we want to know is language of all these 4 different reviews. So if I submit this code here, now once again, you don't need to understand this code. I just want to show you that how we can use this service. Now, our service had identified language of the first review is English and written the code and the score. So one is, that is almost 100% sure that this is English. And once again, for the review 2, 3, and 4, our service returned the languages, score, and the code. Now, let's say we want to know the key phrases from these different reviews. And you can see here that our service has identified these key phrases like good hotel, good service, clean room, and so on from the first review, second review, third, and fourth. And if you just look at these reviews here, by just looking at these reviews, you will get an idea that what are the key points of that review, of that text. What are the key taking away points from that text? Now, if we move further here, the next thing we want to know is the sentiments within those reviews. So once again, if I submit this here, you can see that we have positive, negative, and this is the score we have along with the sentiment. So we can look at that first review is pretty positive, second is negative, and so on. Now, the last thing is we want to know the entities inside these reviews. And once again, if I submit this code, I can see here we have the location, the Royal Hotel, we have another location, London, we have date, time, and few other locations in the review 1. In the review 2, once again, we have few locations here, date, time, and so on. And similarly for the review 3 and review 4. So this is how we can use text analytics service, and we can identify the language, key phrases, sentiments, and entities. And once again, you don't need to understand this code. This is just, I want to show you that how using Notebook, you can call text analytics service. And when you submit these reviews or the text or the document, you can figure out all these different values. Now, coming back to the slide, I have a few questions here, which I want to go through. All right. And these questions are provided by Microsoft. So the first question is, you want to use text analytics service to determine key taking points. So this is the key here, key taking points in the text document. Which feature of the service should you use? And very obviously, we know that this is key phrase extraction, because sentiment return the sentiment of the reviews of the text, whether it's a positive, negative, or neutral, and entity detection return the entities within the text. So for key taking points, we use key phrase extraction. Second question, you use the text analytics service to perform sentiment analysis on a document, sentiment analysis, and the score of 0.99 is returned. What does this score indicate about the document sentiment? Now, as we know that score varies from 0 to 1, and more closer it is to 1, more positive it is, and closer to 0, it is negative. So 0.99 is obviously closer to 1. So this is positive here. Now, when might you see NaN returned for a score in language detection? So when our service not able to identify the language within the text, at that time it returns NaN. And so the answer is when language is ambiguous. And actually I mentioned this point, I forgot to explain during our theory part. So the service will return NaN when it cannot determine the language in the provided text. So the answer of this will be when the language is ambiguous. All right, so few more questions here. All right, so there are few statements here, and we need to identify whether they are right or wrong, whether they're true or false. The first one is return, the results from the key phrase operation in the text analytics includes a confidence score between 0 and 1. Is it right? No, this is false, because not key phrase, but sentiment analysis return score between 0 and 1. The text analytics API can be used with C#. Can it be used with C#? Yes, it can be used with C#. Actually, the text analytics has a REST API. So there's a client library available for .NET, not just for C#, but it's also available for Python, for Java, for JavaScript, Ruby, and so on. So you can use any of these languages to call this REST API. Now the last question is, text analytics can be used by Power App Canvas app to analyze the text. And as I did mention during the theory part, that text analytics service can be used with Power App to analyze text. And there's a text analytics connector actually that can be used to call text analytics from a Canvas app. So the answer of this will be yes. All right, so I hope now you have a better understanding about text analytics service. And once again, in the exam, they just want to know whether you understand what this service is and what this service can do. Thank you. Hello friends, welcome back. And in this lesson, we are going to talk about speech service. Now, this we have already discussed before, and this is the same slide. I have added few more points here which are more relevant from service point of view, Azure service point of view. Now, we discussed that a speech service can do speech recognition. That means converting speech or audio to text. Or we have speech synthesis. That means converting text to speech. Now, when we talk about speech recognition or speech to text API, this can be done both at the real time as well as at the batch time. So you can use a real-time transcription for maybe presentations or demos or any other scenario where a person is speaking at the real time. Or batch transcription, you can have audio recording stored in some file share or remote server, or you can also store this in Azure storage somewhere. Real-time transcription can be of two types. Either it can be conversational, where two people are talking with each other, or we can have simply a dictation. Both are examples of real-time transcription. And if required, you can also train your custom model. Now, when we talk about speech synthesis, we discussed earlier that it is available in multiple languages. You can customize the model. You can adjust the pitch, you can add the pause, you can improve the pronunciation, and all of this can be done using synthesis markup language, SSMS. Or if required, if the existing model is somehow not fulfilling your need, you can also create custom model. Now, we have one more programming interface for speech service, and that is speech translation. Now, when I say translation, that means translating from one language into another language. And we have separate translation service, but that mostly work with text to text. But when I talk about speech to text or speech to speech, we use speech service translation interface. That means speech will be from one language, and after converting into text, this will be of another language. For example, speech in English and text may be in French, or speech may be in, let's say, Italian, and speech may be Chinese. So it will convert from one language into another language. So once again, I repeat, speech service has three programming interface. First is speech to text, second is text to speech, and the third is translation. In translation, we have speech to text or speech to speech. All right, so let me jump back to my portal here and show you that how we can connect with the speech service and can use this model. Now, once again, you have two options. Either you can create the speech service here directly. You can see we have a speech here. You can create this, or you can just use the existing cognitive service which we created earlier. And another thing you may want to note here is that for authentication here, we are using the key and the location. Generally, we use the key and the endpoint to authenticate, but in this case, we are using this location here. So I have already replaced my key and the location, and I can run this to authenticate, and you can see that our service is ready to use. Now, very next step is we are going to install the package for the speech, and then we will install the play sound. All right, so both of these have been done, and this is ready. Now, the next step is we want to use speech recognition with an audio file. So if you look at this location here, data and speech. So if I go here within the data and then speech, we have these audio files here, light on and light off. If you download this here, you can download this from here. and you can listen this. It says that turn the light off. So we are going to use this audio file, and we will see that if our model is able to translate this into a text. So I will submit this code here, and you can see that this has been successfully converted into a text format, turn the light on. So this is how we use these services to convert the speech to text or text to speech. Now let's quickly look at the questions we have here. So the very first question, and this is provided by Microsoft, you plan to build an application that uses the speech service to transcribe audio. So this is the first thing, recording of the phone call to the text, and then submits the transcribed text to text analytics service to extract key phrases. You want to manage access and billing for the application services in a single Azure resource. Now, if you remember, extract key phrases is a separate service. We use text analytics for this. And transcribing audio is a separate service. We can use speech for this. So we use speech for transcribe audio. We use text analytics for extract key phrases. But you can see that this is a multiple choice question. So we have to select one answer. And that's why we have cognitive service here. Because if we have cognitive services, we can use both of these using cognitive services. Now the next question is, you want to use the speech service to build an application that reads incoming email messages. So we want to read incoming email messages, subject allowed. So that means we want to convert the text to speech. So this is the API we want to use to convert our email messages into audio format. Now let's look at a few more questions here. All right, so we have few statements here, and we need to figure out if they are true or false. So the first statement is, to use the speech service, you need to build a custom speech model. Do we need to create a custom speech model to use the speech service? No, this is false. Why? Because we already have pre-built model from Microsoft. However, if you have a very specific need, maybe you want to have some very specific language or some specific kind of noise or something, then you can use custom model, but you are not forced to use it. You can use a pre-built model. The speech service can transcribe audio streams in real time. So the answer of this is yes. So basically the speech service can transcribe audio streams and even local files in real time. We can use it to maybe in a combination of other cognitive services. For example, we can use language understanding service, and this can enable real-time interaction between users. For example, maybe you want to understand their vocal commands and perform some kind of operation. Then it can be used in collaboration with other services, and we can do this at the real time. Now the third statement is, the speech service can transcribe audio files asynchronously. Is this true or false? This is true. If you remember, we discussed about the batch processing. So the speech service can transcribe audio file asynchronously. We can have a large amount of audio files, and we can upload it maybe in Azure storage, and we can process these files asynchronously using the speech service through the RESTful batch speech to text interface. So I hope now you have a better understanding about the speech service. Thank you. Hello friends, welcome back, and in this lesson we are going to talk about translator service. So what is translator service? In a very simple terms, translator service translate your text from one language to another language. And we can do this at near real time. Now, so for example, let's say you have text in the English language and you want to convert into, let's say, French language. You can do this using translator service. And not only that, if you like, you can translate this text into multiple language. So when we call this service, we have option from and to. These are parameters. So in the from, for example, we pass English, EN. And in the to, we pass French and Chinese and maybe Italian and maybe other languages. So we can convert this text into multiple languages at the same time. Now, we can also specify cultural variant. For example, we can mention French, not just French, but Canadian French here. Now, next important point here is translator service can be used only from text to text. It supports only text to text. If you have an audio file, if you have a speech, and you want to convert into or translate into another language, you have to use speech service. And we discussed this when we were discussing about the speech service. So from speech to text or speech to speech, basically from one language into another language, from one language into another language. But if the source is speech or the audio file, we will have to use speech service. Now, another point from certification point of view that this service use neural machine translation, NMT model for translation. Now, let me go back to the portal here. And once again, we have been using this demo provided by Microsoft. And I hope you have been following this course where I explained that how we can copy this from GitHub. And we have covered all these different notebooks. And in this demo, we are going to use this translation notebook. Now, the very first step is we want to authenticate to the service. And we have option to create a translator service. For example, if I type search for the translator, you can see that we have translator service. But as we know from the previous lessons that we can create a cognitive service, which is kind of umbrella service, so that we don't have to create all individual services separately. And by using this service, we can use all the service. So I'm going to use key and the location from this my cognitive service, and I will replace it with the variables here, and I can run this. Now we are ready to use cognitive service. Now, the very first step here we want to do is we want to convert our text from French to English. And this is the text. The text to translate is hello. So let me run this here. And you can see that we have translated our text, from English to French, hello to bonjour. Now, we can also change this text. For example, I can say it's a rainy day. And if I run this code once again, it's a rainy day, and this is the text in the French language here. Now, in the next example, we are going to see that how cultural variant we can add to translate from one cultural variant or one language into another. For example, here we are trying to translate from English, but this is British English to Italian. So if I run this code here, now in Italian, it is called ciao. So basically, if you see here, English is British, or we can also mention English in US, that means US based English. Now, another example we have here is what we are trying to do here is we are trying to translate from US based English to Chinese. So let me run this code here, and you can see that this is the Chinese text we have here. Now, we also have option, as we discussed, about the speech translation. So we have an audio file here, and if you look at this is the location of audio file. If you go into the data and translation, so for example, on the left hand side, if I go into the data and if I go into the translation, we have this audio file english.wav file, and this is the audio file which we are going to convert into text, and the text will be in the French language. So you can see that the file has hello audio file, and hola is the French language translation we have here. Now in the very last part, once again we have audio in the French language, and this is the name of this audio file, french.wav, and this we want to convert into English language. So if I run this code here, you can see that we have the French word here which we are translating into an English language. So this is how we can use the translator service to translate text from one language into another language. Now coming back to my slides here, let's look at what kind of questions you are going to see in the exam. So very first question is, you are developing an application that must take English input from a microphone. So this is the audio file, and generate a real-time text-based transcription in Hindi. Which service should you use? And as we discussed that when we have the source as an audio file or a speech file, we use a speech translation service. So this is the right answer. Now, second question, you need to use the translator text service to translate email messages, that means text, from Spanish to both English and French. So that means multiple languages. What is the most efficient way to accomplish this goal? Make a single call to the service specifying from language to English and to language to English and another to language to French. So once again, this is the right answer. And if you look at the second option here, we cannot have like English and French like this. We can mention like English and French like this in the comma separated format. And in the third option, it says we need to make two calls, two separate calls. It's not true. We can make one single call. And in the single call, we can mention multiple languages in the two, and we can accomplish this task. So first one is the right answer. Now let's look at one more question here. And here we have few statements, and we need to figure out if they are true or false. All right, so the first statement is the translator service uses statistical machine translation SMT technology. Is this right? No, this is false, because we discussed that translator service use NMT. Now this is the latest technology. Earlier it was using SMT. From 2016, service started using NMT technology. So this is the false answer. The translator service can simultaneously translate from one language into multiple other languages. Is this true? Yes, this is the right answer. And we have discussed this multiple times already, that from one language, this service can translate into multiple language at the same time on the same call. Now, third statement is the translator service supports translation into language variant, such as French or Canadian French. Is it true? Yes, we discussed that. We can have language or cultural variant, and service can translate from one language into another cultural variant. So the first one is false and other two are true. So now I hope that you have fairly good understanding about translator service. Thank you. Hello friends, welcome back. And the goal of this lesson is to understand language understanding. Now we discussed about this earlier, that language understanding basically extract the overall meaning from the text. So user provide the text, this is the input. And when we extract the meaning of the text, we extract the intention behind the text, and we extract the action we need to take, or the action which is expressed in the text. That is called language understanding. And we also discussed the three important concepts here, that is utterance, entities, and intent. Utterance is basically what user provide as an input, the whole sentence, something which users say. Entity is basically the item on which utterance refer. So for example, switch the fan on. So entity is fan. This is the item which utterance is referring here. Turn on the light. So light is the entity here. And then we have the intention or the intent. That means the purpose or the goal which is expressed in user's utterance. So for example, switch the fan on, switching on, that is the action, that is the intention. Turn on the light, so turn on is the intention. Now, when we want to use language understanding service, we need to create two resources. The first one is the language understanding service, and we need this service to train, basically to define, to design, to train and to test our language model. And once we have this, we can either create a cognitive service, or we can keep using language understanding service here to publish the model and to handle the request, to use that model. So in this demo, we are going to create a language understanding service. We will define, train, and test our model. And then finally, we will use our cognitive service, existing cognitive service, and we will use that model which we published. So let me switch back to my portal here. And if I search here, language understanding, you can see that we have language understanding service here. So I can open that, and we can create new language understanding service. And you can see that we have option for authoring or prediction and we can basically create just for the author or just for the prediction, but in this case we can create for both of them. And then we need to select our subscription and our resource group here, and then we need to provide a name to our service, so maybe language understanding 108, just to keep it unique. And then we need to define our authoring resource here, and the location I will choose as a West US. And here you can see that we do not have a whole lot of list of location. We just have this available in Australia, West Europe, West US, and Switzerland. So I will choose West US here, and the pricing tier I will just choose free. And once again, for prediction resources, I will choose West US, same location here, and pricing tier once again I will choose as a standard SO. And then I'll just click on review and create, and it looks good, and I'll just click on create, and this will create my language understanding service. Now once we have this service created, it may take a few minutes here, so probably I'll just stop my recording and I'll come back as soon as this complete. All right, our resource have completed successfully. So I'm right now inside my resource, but I want to show you here that if I go inside my resource group, you can see that two separate resources created here, one for the authoring and one for the prediction. Now going back to the resource here, now what we are trying to do here, we are trying to create home automation application. Now in this application, if I provide input like turn on the fan or switch off the light or turn off everything like that, then app should be able to take action on this input. Now to create this app, we have to open another portal here, which is LUIS language understanding .ai. And if I open this app, and if you're opening this first time, maybe you have to sign in, maybe you have to choose your subscription, and then you have to choose your resource here. So for example, we just created a resource, language understanding 108. So I will just choose it here, and I'll click on done here. Now, once we have it here, as of now, we do not have any app, and we need to create a new app. And in this app, we will be configuring different entities, different intents, and different utterances. And once we define all these, we will train this app, and then we can test it. And then once we are satisfied, we can publish it. All right, so let's click on new app here, and we need to provide the name of the app here, which I will say home automation. Our culture is English, which is fine. And description, I can just say that simple home automation here. And predicted resource should be language understanding service, which is just created. So I have chosen my service here, and I will click on done here. So now this is creating a new app, and in this new app, I can close this window here. And in this app, we need to define our intents, our entities, and we need to define our utterances. And then we have to train this app, and then we have to test it, and finally we have to publish it. All right, so the first thing we will do is we will create entities. And once again, entity is that thing that your language model can identify or can do something with. So for example, your language understanding app will be used to control various devices in the office or in the home. For example, the lights or fan. So you will create a device entity that includes a list of all the type of devices that you want the app to work with, that you want your app to handle with. So for example, let me click on create here, and I can create a new entity, for example, device here, and I can select as a list type, and I can click on create here. Now inside this list items, I need to add various devices. So for example, I can say light, and I can press enter. Now light is added, but we can also have synonyms of light. Maybe user can say lamp instead of light, and I'll press enter here. And I can add another item, list item here. So maybe I can say fan, I'll click enter here. And instead of fan, user can say AC. So I will just enter it once again. So you can see that we have two devices added here, fan and light. Now, while adding these devices, you want to make sure that you use the lowercase and should not have any extra space here. Now, the next thing we need to do is we need to create an intent. So I'll go to the intent here. And once again, intent is basically an action that you want to perform on one or more entities you have defined here. So for example, you can say that turn on the light or turn off a fan, for example. So these are the intention. These are the actions we're supposed to take. So in this case, we will create two intents. One is switch a device on, and the second is switch the device off. And device can be anything. So for each intent, basically we'll specify some kind of sample utterances that indicate the kind of language used to indicate these intent. All right, so let me create a new intent here and let me say switch on. And once again, just keep a lowercase here. And I can just click on done here. And then I need to provide some example of utterances, what user can provide as an input. So for example, I can say turn the light on. So this can be one example. And if I click enter here, now this is added here. This is the sample of utterance. And if I click on light here, I need to associate with this with the device, which is the light. Let's add another example here. Turn the fan on. And once again, I will associate or attach this with the device called fan. All right, so we have defined a switch on. Now I will again click on intents here. You can see that we have switch on, and I will create another intent that is switch off. And I will just click on done here. And now once again, I will provide example here. So for example, turn the light off. And once again, I will assign the word light with the device light here. And then I can say turn the fan off. And once again, I will assign this fan with the device fan here. All right. So if I go to intents here, we have two intention, we have two actions, switch on and switch off. And these are the entities like devices on which we can take action. So for example, we have fan, light, and we have given the examples here. So everything looks good here. I will just click on train here to train our model. And once our model trained, we can test it and we can provide different inputs there to see that if it is working as expected. So we can see that training has been completed. So I will just click on test here. And I can provide some utterance, for example, switch the light on. And you can see that if you go to the inspect here, it has taken the action switch on and on the device light, which makes sense. That's what we want here. So let's try one more example. Turn off the fan. And you can see that once again, it has taken the action, which is switch off, which is fine. That's what we want. And the device is fan. So it looks like our model is working fine here. So I will just go ahead and publish my model. And I will choose production slot here. And I will click on done here. Now, once this is published, it will give us the endpoint which our client application can use and can send new utterances and can use this model. Now, once the model published successfully, so we can see that publish app has been done. I can click on manage here, and here this app ID is important. Now, if you remember, we created these resources, and we have two resources. One is authoring, which we are using right now, and another one is prediction. So if I click here to our prediction resource, I can go to keys and endpoint. And I can use these keys and endpoint for this prediction resource. Alternatively, we can also use cognitive service. So if you remember, if I go back to my slide here, for the authoring resource, we always have to use language understanding. But for prediction resource, we can use either language understanding or cognitive service. So we have both of these options here. All right, so I will just use this new resource here, prediction resource, which we have created anyway, and I will take my key and endpoint from here. So I'll just copy my key from here, and I can replace my key here, and then I can take my endpoint from here and replace it with here. And finally, we need the application ID, which we have just created. So once again, I have taken from manage this application ID, and I will replace this application ID from here. All right, so this looks good here. And if I run this this code here, we have a command here which we need to put. So for example, I can say that turn on the light. And if I submit it here, you can see that it has rightly predicted the entity, which is light, and the intention is switch on, and it has returned us this image, which is mentioned in our folder here. So we can change this image. This is the location of image data and LUIS. So if I go to the data, if I go to the LUIS, there are images which we can use for turn off the fan, of the light, and so on. If required, we can change this image also. But the point here is that our model has rightly predicted the intention and the entity here. Now, in this case, we were providing command in the text format here. But what about if we have the voice control? Instead of giving the text command, if we just give the speech command or the audio command there. So our service or our model should be able to handle that also. And now this time I'm going to use my cognitive service, and once again I will copy my key here and I will just replace it here, and the location is West US 2, which is already here. So we are good. Let me authenticate myself to this cognitive service. And once we have here, you can see that in this code we are providing light off. This is the wave file, this is the audio file. And if I submit this code here, you can see that turn the light off. So this is the input, turn the light off. So basically it converted audio into text, and when we submit this, it has rightly figured out the intent, which is switch off, and the entity is light here. So it has switch off, off the light. So this is how we can see that using our language understanding model, we can give the utterance or the input, whether in the form of text or in the form of voice or the audio, and our model is able to understand that, able to figure out the intention or the purpose or the goal of that command and take action accordingly. All right, so coming back to my slides here, I want to show you a few more examples which I have taken from Microsoft, that there may be different utterances like switch the fan on, turn the light on, and so on. And we know the intent behind these utterances. What is the weather for today? So check weather is our goal, and today is the entity. Now, sometimes user enter utterances which does not really make sense, or that does not really have any purpose behind it or some kind of action behind it. So for example, user can say, what is the meaning of life? Now, there is no goal, there is no action expressed in these utterances. In that case, we return none as an intent. So basically, none intent is considered some kind of fallback, and we can use it, typically we can use it to provide some kind of generic response to the users where their requests don't match any valid intent. Now, let's look at some questions which may help you further clarifying your concept. So the first question is, you need to provision an Azure resource that will be used to author a new language understanding application. What kind of resource should you use? So this is about author. And we know that for author, we always have to use language understanding. For prediction, we can use either language understanding or cognitive service. But for author, we always have to use language understanding. So this is the correct answer. Second question, you are authoring a language understanding application to support international clock. This is what we need to design. You want users to be able to ask for the current time in the specific city. For example, what is the time in London? So this is our utterance. What is the time in London? what should you do? Now, the first option is define the city as an entity and get time as an intent. So this makes sense. So what is the time in the London? So London is the entity here, and getting time is the intent here, is the action which need to perform. So it seems like this is the right answer. Now, the third question is, you have published your language understanding application. What information does a client application developer need to get prediction from it? The endpoint and key for the application prediction resource. And this is right. We get endpoint and key from prediction resource. From authoring resource, we do not get the endpoint and key. We get the application ID, which we just saw during our demo. We get the application ID from authoring, and from prediction resource, we can get endpoint or key, or alternatively, as you know, that we can also use cognitive service. So this is the right answer. Now moving forward, we have one more question here. Which two Azure cognitive services can you combine to recognize intents in the voice command? Each correct answer presents the part of the solution. So what are two services which we can combine to get the voice command? So the first is language understanding and the second is speech. So the speech service enables the real-time transcription of your voice commands from your audio stream into a text, and then this language understanding can process the user conversation text to predict the overall meaning and return the dedicated intent back to your application, which your application can take action on. So language understanding and speech. Speech is to convert audio to text, and language understanding to fetch the intent, the action from that text. So I hope now you have a better understanding about language understanding service. Thank you.